Hello and welcome to Tuesday's lecture. Today we're talking about writing the equation of a line given the y-intercept and the slope. We're also going to add something a little bit extra into it that will also complicate things a little bit, but hopefully with the work that we can do today, we can make it useful, okay, and make it understandable more than anything. So let's get right into it. Remember what we're looking for. This is always important, and I do say it every day because it's important every day. We're trying to find the equation y equals mx plus b, where m is the slope and b is the y-intercept. So as the first round of problems today, where I'm telling you the slope and telling you the y-intercept, it's almost easier than yesterday's. Yesterday I had you do it with a graph. I had you find the slope and the y-intercept on a graph, and that's relatively easy. It's a counting problem more than it is a math problem. Now arguments are out on whether or not counting is real solid math or not. Yes, math is involved, but it's a counting problem. Today, I'm telling you what the slope is and telling you what the y-intercept is, and I'm saying write it in this fancy form that tells me what the slope and the y-intercept is. So, if I tell you the slope is 5, that means that m equals 5. If I tell you the y-intercept is -3, that means b equals -3. Well, at that point, it's a problem of, can you put the 5 where it has to go? Remember the x. I still have students that forget the x. And put the b where it has to go, -3. Okay, that's that problem done. I don't want to make it harder than it has to be. But this is one form of how I could ask that question. I could write out that slope is this and y-intercept is this. I could also say that m is -1/4 and b is +6. It's another way to say that. Obviously, it's not the same problem. We're talking about a different problem here. I know that kind of sounded like a math. Oh, you're going to get the same answer. You're not, but you do the problem the same way. You put the m in for the m and the b in for the b. So we take 1/4 x plus 6, and that's that problem done. Okay. Now another way that I could ask similar problems is I can still give you the m, or I could have said slope here, right? That means the same thing. And then I say it goes through this point 0,5. Now let's think for a second what the point 0,5 represents. Okay? If I think about having a graph, right? I'm just going to draw just a quick graph, and my job is to, wrong button, my job is to plot the point 0,5. Okay, that means that the x-coordinate is 0 and the y-coordinate is 5. So I don't move anywhere left or right, but I go up 5. That right there is the point 0,5. And if a line goes through that point, any line whatsoever, if a line goes through that point, okay, well, you've actually got to go through the point to say you're going through the point. If a line goes through that point is the y-intercept. And it all comes down to, because of the fact that the x-coordinate is 0, whenever the x-coordinate is 0, let me make that apparent. Whenever the x-coordinate is 0, the accompanying y-coordinate is the y-intercept. Or you might say it is b. So this whole thing, this whole statement here, through 0, -5, is really just a fancy way of saying that b equals 5. Don't know why I did that. I don't know why I put a parentheses there. It's just a fancy way of saying that b is equal to 5. Okay, so now this problem is just like the ones that we had up above. That m equals 3, b equals 5. Write your equation. 3x plus 5. And there we go. Same thing with the last one over here. We just have some fractions involved, but that's okay. Slope of negative 2/3. Negative 2/3 x. Through 0, negative 2. Again, since this is 0, this negative 2 is my b. Right? And it says b equals negative 2. So we put a negative 2 there, and we're done. Don't make those problems harder than they have to be. If I tell you the slope and tell you the y-intercept, putting it in slope-intercept form is something that should be manageable. Okay, that's our goal. All right, now for kind of a new talk. Right, we dealt with that side of things. Let's look at it this way. I have 3 lines here, and I want to find the equations of all 3 of these lines. Okay, so this is sort of a review from yesterday, but a review for a good purpose. Okay, I'm trying to find the slope and the y-intercept of each one of these lines. If you watched the video yesterday, or if you were in class, I usually think to start at the y-intercept. Well, that y-intercept at negative 5 means b equals negative 5. And I'm looking for my next point. There's a point right there. To get from this point to that point, I go up 1 and over 2. Up 1 and over 2 means that the slope is up 1 and over 2. So this blue line has the equation y equals 1/2 my slope times x minus 5. Okay. Let's look at the green line. Goes through this y-intercept, b equals negative 2, and it goes up 1, and it looks like it goes over 2. It looks like it goes through right there. So 1 over 2. So my slope is 1/2 again. Making my equation with my slope at 1/2, 1/2 x, and a y-intercept at negative 2. Okay. Last but not least, let's look at the red line. Let me clear out some of this other stuff so I get a little bit better visual. Find your y-intercept. B equals 2. Find your slope. I've got to find another point. Let's use that point right there. To get from this left point to this right point, I go down 1, down 2, and over 1. Down 2, over 1. So my slope is negative 2 over 1, which I understand we would probably say that that means it's negative 2. So just bear with me that I'm going to say that it's 2 over 1 for now. I'm doing that for a reason. And we had a y-intercept at 2. So those are those 3 equations. But if you notice on the left, I'm not talking about those equations at all. I'm talking about parallel lines and perpendicular lines. The blue and the green line are parallel. Blue and green lines are parallel. They're never going to cross. They're going to keep going the same way for the same amount of time. And that means they're parallel. But equation-wise or slope-wise, what do you notice about the slopes of these two? It turns out that their slopes are the same. Or, I guess, mathematically, we would say that parallel lines, these two lines that are parallel, have equal slopes. Okay? If two lines are parallel, one slope equals the other slope. Think of it this way. If these two lines had different slopes, let's say that this green line went through this point, but it went up 1 and over 3 instead of going over 2. It went up 1 and over 3. Then just lightly sketching this in, we would see that eventually these two lines are going to cross. I'm not trying to force them to cross. I see it's kind of bending down. I'm trying to make it straight. But eventually those lines would cross. And that was with a slope of up 1 and over 3, not far off of that up 1 and over 2. In fact, if it's anything but up 1 and over 2, that green line is going to end up, I wish I would have put that in green now, that green line is going to end up touching that blue line. And so yeah, it's kind of my red line here, but started at the green line. Total sense. Love it. Makes a lot of sense. Okay, so in order for two lines to be parallel, they have to have equal slopes. They have to grow over time at the same speed. Otherwise, one of them is going to catch up to the other one. Okay, and it may not be something that happens within your graph. It may be something that happens in the future, but or even in the past, you know, off to the left or off to the right. They're going to meet somewhere. Okay, that's the easier one of the two. But if I said, hey, find me a line, let's go look at that one right now. Write the equation of a line, and I'm looking at this one where it says parallel to this line, and it goes through the point 0.05. Well, we've already talked about this part. This means that b equals 5. That's still the same. So in this new line, I'm going to have something fancy like y equals some number of x's. You know, I'm looking for that piece, plus 5. So I've got that in there. My b is in there. That's good. Okay. Now let's talk about the slope, though. Because I have, it says parallel to y equals negative 5x plus 2. Well, parallel lines, we just said, have the same slope. And it turns out that in this entire equation that they give me, the only thing I care about is what the slope is. This could have said negative 5x, you know, plus 2 million. That wouldn't matter. None of this over here matters. I mean, even this part doesn't matter. I need to know that it's in slope-intercept form, but those numbers, those values don't matter, and even that x doesn't matter. I just know that I need the same slope as what this one has. So we would say that a line that's parallel to this line that goes through negative, or that goes through 0.5 would be negative y equals negative 5x plus 5. Same slope, different starting point, if you will. Okay, let's go back to this one, and let's look at the similarities and differences, I guess, between the red line and either the blue or the green line. It doesn't matter. It turns out that this red line is perpendicular to both the green line and the blue line. If you don't remember what perpendicular means, that means they meet at a right angle. They meet at a 90-degree angle, like what you usually find in corners of rooms or windows or anything like that. Okay, we have a lot of right angles out there, a lot of perpendicular lines out there, because it's aesthetically pleasing for things to be perpendicular and parallel. That's what makes like rectangles. Okay, so we just like those, and we use those in building a lot because it's also, not only is it nice to look at, but it's also stronger. Okay, so when we look at these two equations, let's pick on the green line and the red line. We're looking at these two lines, and they are perpendicular. But what about their slopes makes them perpendicular? I notice that one of them is negative 2 over 1, and the other one is 1 over 2. Well, how do I either turn negative 2 over 1 into 1 over 2 or 1 over 2 into negative 2 over 1? Well, you should see kind of a flip that's happening, right? One of them is the other one flipped over. There's also a sign issue. One of them's negative, one of them's positive. Now, I don't ever want to say, if I mean to switch the sign, I never want to say, well, make it negative. Well, what if it's already negative? What do you do? Well, then you'd make it positive, right? You don't want to say it that way, so I guess it's probably better to say switch the sign. Mathematically, we call that its opposite. Okay, we call that its opposite. And that really just means switch the positive or negative to its counterpart, to its other one. But it's the opposite. It's not enough, though, to say that perpendicular lines have opposite slopes. Because opposite of, let's say, this 1/2 would just be negative 1/2. So it's not enough to just say it's opposite. Because this slope is not negative 1/2, it's negative 2/1. So it's the opposite and it's flipped over. We call that the reciprocal. Okay? And that just means flip the fraction. And that's enough to describe how we come up with perpendicular lines. Perpendicular lines have what we call opposite and reciprocal slopes. So we switch the positive and negative sign and we flip over that fraction. Okay? Here's a question I have for you. If I said, and let's just practice this, I want to find perpendicular to a line that has a slope of 5. What is the perpendicular slope to 5? So opposite, change its sign. Reciprocal, flip it over. Well, call me crazy, but whenever I think of flipping over a 5, it kind of looks like a 2. Okay, that's not here nor there. That's just a little math humor for you. Visually, it looks like flipping that 5 flipped over is kind of like a 2. We have to remember that any whole number is always over the number 1. That allows me to actually have a fraction to flip. So if I turn this into its perpendicular slope, kind of my new slope, would be that flipped over and change the sign. Change the sign to negative and flip over that fraction. Don't just flip over a 5, okay? Even though that is kind of cool that that works out. So let's do that last problem that we have. So I want perpendicular, oh, this one's negative 5, but y equals negative 5x plus 2. It's that same equation from before, and it goes through the point 0, negative 3. Again, that just means that b equals negative 3. And now I just need to find out what my opposite reciprocal slope is. Again, we take negative 5, write it as a fraction. Whole numbers are fractions too. They just have 1 in the bottom. Switch the sign from negative to positive, and then flip the fraction. So we switch the sign, and we flip. Don't get that confused with your keep, switch, flip that you may have heard in other classes. But again, the only thing that mattered here in all this information, because that's great information, that we have a line that's y equals negative 5x plus 2. The only thing that we used was the negative 5. Okay, now I have my new slope and my new y-intercept. Write the equation. 1/5 x minus 3. And that's all there is. Okay, if that helped out, great. If it didn't, make sure you get in touch with me somehow. And other than that, have a great day, and we'll see you in class.